Otherwise, you need to keep it all the time open, no?
Yes, yes.
So that won't work. So oil has to go up, no, not here. So this has to operate somehow. There are two solenoids here. So I can suggest you one thing.
Aaron, please go.
If there is a blackout, immediately come down to engine room and then open this. But that is too late.
But wouldn't be it better if it would be first closed with power, but if the power would go off, it would automatically open.
To open something, we require energy, you know. So now if you look at this valve, there is a mechanical option, opening. So here you got a spring. The spring keep it closed all the time. So this pressure is acting here. So when the pressure is acting and overcoming the spring force, then the line comes in line, no? Then only oil can drain. So we need to work to open it. We need energy. Okay, what will happen is this solenoid will operate. If you click on this, you will have a little window coming up here, which will show you open ACU1, open ACU3, and close. These two solenoids are connected to ACU1 and ACU3. Okay, there are two. It's basically given for redundancy. The moment the blackout is happening, tuck, this will open automatically by both the ACUs. You have both. One of them is not working, the other one will take care. Now my question, how in a blackout situation the solenoid can energize?
So there is a spring, what is kept, and during the blackout.
No, the question here is not that. No, that's okay. The question is how the solenoid will get energized when there is a blackout. So which means we need to send electricity, you know. Then only solenoid will energize.
There is a backup power.
Backup power from where? Your emergency battery in the on the bridge deck. That one.
ACU will have a backup notice. ACU will be a signal.
Okay. So the question here is, you forgot what we spoke on the first day.
30 minutes.
Yes, 30 minutes. Your MOP, all MPCs will have power supply. 30 minutes. The power supply coming through the battery, online UPS. So all these things you can operate for 30 minutes if you want. So those battery power supply will energize this and release the pressure what is available here. That much oil will come here and then keep recirculating. Open this, close this. The pump will not run. So these ones are for pump failure, electrical failure. So this is to take care of the custom running. So this will be. And one more thing I want to tell you here, this valve will also open whenever there is a shutdown. So it's like a shutdown solenoid. It will open up and immediately release the oil pressure. Very quick. Whether it is emergency stop, jacket temperature, high temperature, shutdown, or whatnot, it will shut down. It will open immediately. You can. I told you how to release the pressure quickly. You open this manually, but to open this, you need to have manual selection. Then you can open this and release the pressure if you want to release the pressure very quickly. So that is about this, and this is the last kind of difference. If let us say suddenly engine is stopped from full ahead, a case like this, so pressure will increase because the pumps are running still, and there is inlet pressure available here, and there is no consumption on the top. So 230 bar. Now pay attention to me. This Oil will come here and push the spring. Then this valve will open. So to open this, I need to overcome the spring force, be it oil pressure, be it solid. So this operate, you require energy. So 230 bar, still pressure is not able to control because of the pipeline diameter is restricted. So then you will also have this valve opening at 250 bar and release. This will open only at 250. If 230 can take care, this won't open. So that is how it is. And for 300 bar system, it is 310 and 315, and this is 220.
So while doing the fuel and exhaust valve overall, anything we have to do, sir, to reduce the pressure? But
Fuel
normally
injection. Fuel injection is only on the fuel side, no? So you can stop your fuel system, drain the fuel or pressure. And anyway, when you do that, probably you would be stopping the engine, no?
yes. So the pressure will be anyway down. So no need to do it.
You'll do the finish with engine, hopefully.
Yes, sir. Yes, sir.
One of the training club courses, we come to know that one of the second engineer was asked to change the fuel pump on MC engine at decimal speed. So the chief engineer had done it in the past. And he said, yes, he did it. And I also know some guys say they can change the fuel valve of the running engine. So please don't do it. Probably when you slacken the bolt, no, the fuel valve will fly like a rocket. It is also been discussed. So hopefully you should stop engine. Follow, there is a little thing given to the ship. Of course, to touch that you require gloves, goggles, and dust mask. That thing is called instruction book. Okay.
So for during maintenance, no need to depressurize any. We don't have to do anything in the hydraulic system. That's right, sir.
But when you do finish with engine, anyway, your oil.
Yeah. I know. Yes, sir. I'm just asking, sir. Yes, sir.
No. But if you are working on hydraulic system, yes, you need to do. We'll show you that tomorrow. What you
Okay.
have to do. I think today afternoon. Sorry.
Okay. Sir.
So hydraulic system, how even you can change the fuel valve when engine is running. No problem. Not fuel valve, fuel valve. So we will show you how to do that.
Okay. Sir.
Okay, this is a very important slide. Anybody has any other questions? A lot of information has come from here.
So how do we know the performance of any one pump is going down, sir? Like the hydraulic, the built-in pumps.
These ones, very
Yes,
simple.
sir.
Very simple. Let's say when you go on the ship, engine running at 80% load. See what is the angle here. Just make a note of it. Run to 90%. Make a note of it. 70%. Make a note of it. Of course, this will be there in your CTL data also. Now, after 1 year, you went back to same ship. At 50% load, these are increased by, let's say, 5%, 6%, 7%. So then you can make out something is going wrong. You cannot pinpoint is the pump. Why? If there's internal leakage, still the pump angle will go higher. So that will tell you your hydraulic coil is no more tight. That way you can make. Now what you can do, when you put this as a controlling pump, you see what is the angle here. So you are doubting this pump is leaking. I mean performance is gone. So now you put this pump as the controlling pump, which is very good pump. So it will come to 50%. Right? Then see how much is the angle on the follow-up. It's a very rough way of calculating. Unless the leak is so much, internal leakage is so much, you can't make out. But that will give an indication. You change the controlling pump, which is always running at 50%. You make out the follow-up pump's angle. Which you can see. They are all 54, 50, 54, everything is good. Follow what I'm saying.
Yes, sir. Copy, sir. I understood.
So that way you can do. And at the same time, all of them are going higher, both of them. Then it will be leakage somewhere. Okay. So I had come back to the there's a logic gone on the inlet sensor that I'll tell you.